Okay, so the wave equation as in the case of heat equation, we will derive the wave equation. Okay. Mathematical formulation and uniqueness results. Okay, so this time we have something like this. Let's say we have a string of length L. So this can be the guitar string like this. Okay, and it just oscillates. Okay, up and down. All right. So we assume the following. The string we assume that the string is made of a homogeneous material. Yani bir yeri kalın, başka bir yeri ince veya bazı yerleri daha ağır, bazı yerleri daha hafif değil. Hani böyle homojen bir yapıda. There is no effect of gravity and external forces. And third, onu şuraya yapayım. Şunu silip tekrar yazarım. The vibration takes place on a plane. Yani şöyle kabul edebilirim. So we have a guitar string, let's say, of length L, like this, and it oscillates up and down. Gravity, yani gitarın teline tabii ki etki ediyor ama hani onu çok az kabul edip neglect ediyoruz. Normalde hani gravity, değil mi? Böyle bir teli büker. İşte telefon telleri, elektrik telleri. Gerçi artık telefon teli yok. Onlar yer altından gidiyor. Ama elektrik telleri, değil mi? Elektrik direkleri veya çamaşır ipi şöyledir. Bunun şeklini biliyor musunuz? Evet, değil mi? Cosine hyperbolik x gibi olur. Parabol değil. But so we assume that there is no gravity effect on this string. Now, let's say this is the point x, and this is the point x plus delta x, and this point is, let's say, P, and this point is Q. This is the tangent line here. This is the tangent line here. let's say this angle is how much? This is, let's say, amma küçük yazmış burada. Okay, theta 1 degrees and this is okay. Şunu biraz daha büyük çizeyim de. Okay, let me redraw this. Yani daha belirgin olsun. Okay. Okay. So x delta x no, böyle olmaz. Şöyle olacak. Okay. Yani bu da çok iyi olmadı da. Bir türlü çizemedim. Okay, şöyle yapayım. Şunu biraz daha yakın alayım. X plus delta x. Okay. So this angle is theta 1. This is theta 2. Okay. Theta 1 and theta 2. So the angle between the tangent line and the horizontal line. All right. Okay. So let T1 and T2 be the tensions at the endpoints. P and Q. So this point is P, this point is Q. So we have, you know, this, let me redraw this piece of arc. So this is the string. Okay, this is the point P, this is the point Q. And there is this tension here, P1, acting to this end, and tension T2 acting to this point. Yani teli şurada çeken kuvvet, bir de burada çeken kuvvet, değil mi? So these are the forces acting to this wire at the endpoints. So here it's pulled this way via the force T1, and it is pulled at this point in this direction via the force T2. We call them tensions. Okay? Yani teldeki gerilmenin ürettiği kuvvet. So that's the force produced by the wire at the two ends. Of course, that force is in the direction of the tangent, you know, line. Okay, then we have what? Since this piece of wire doesn't move horizontally, the total force acting on this horizontally is 0, because, you know, this piece doesn't move horizontally, it moves vertically. So this means what? The horizontal forces, so T1 times cosine theta 1 is T2 times cosine theta 2. So here, this angle is theta 1, and this angle is theta 2. So the horizontal piece of this, which is this force, is equal to the horizontal piece of T2, which is this force. So they are equal, okay? So that's expressed via this equation. And let's call this T, and that is constant throughout the wire, which is constant at each point. At each point, the tension is the same. Okay. All right. The difference of the horizontal forces, the difference of the horizontal forces is how much? It is just T2 times sine theta 2, and then T1 times sine theta 1, right? So this force has this much, which is T1 times T1 times sine theta 1, and here there is vertical force, which is just the vertical piece, which is just T2 times sine theta 2. And one of them is downward, the other one is upward. So the upward force is just T2 times sine theta 2 minus T1 times sine theta 1. And this is the total force acting on that piece of wire. And that's equal to what? That's equal to of course, mass times the acceleration. What is the mass of this? So this is just mass times the acceleration, where m is the mass and a is the acceleration, right? By Newton's law. Which law? Second law, I guess. What is mass? Well, this is a homogeneous piece of wire. The mass is just the length, the mass of unit length times total length. Total length is just delta x, delta x. Yani aslında delta x değil ama herhalde çok fark etmiyor. Okay, so I guess they just approximate the length of this. So assuming that the wire doesn't move much, so they just approximate this length by delta x, and then rho, which is the density. Rho is, let's say, in grams per santimeter. Yani telin her gramının, özür dilerim, her santiminin ağırlığı. So this is the density of the wire, which is grams over centimeter, let's say. And then you multiply with the length of the wire, approximate length of the wire. So you get the mass. Yes, vertical. Well, I drove them vertical, but said they are the vertical forces. Horizontal forces are equal. Okay. Peki, what is A? A is the acceleration. Well, if acceleration in the vertical direction. So I have this wire at any x and time. Uxt is the vertical distance of this point from the equilibrium position. So what is the vertical velocity? U is this, so is the vertical distance. So vertical velocity is just u sub t, right? T derivative of this, right? T derivative is the velocity. What is the acceleration? Well, it is second derivative. So it is u sub tt xt. Therefore, this is just delta x times rho times u sub tt. Yes. Tamam mı? Here, of course, to approximate this length by delta x, we have to assume that this piece of I mean the wire doesn't vibrate too much. Otherwise, this arc length is not this. It should be right. Arc length should be delta x times 1 plus u sub x squared, right? It is the x derivative. So arc length for a curve, right? What if you have a function y equals f of x? So what is the arc length here? Arc length is just delta x times. So arc length is very close to the length of the tangent line, and so it should be, it should be multiplied with this. But here, I guess we assume that, this is very small, so that this delta L is almost delta X, assuming that this doesn't get high much. Okay, nevertheless, that's the model. So then we do what? Yani orada öyle bir kabul yapılmış sanırım. Hani x yönünde ki değişimi u'nun çok fazla değil diye. Şimdi buradan şunu görebiliriz. Herhalde. Yani telin uzunluğu evet çok değişmiyor olması lazım. Evet. Demek ki hani okay. So we have T2 divided T2 times sine theta 2, T2 divided by cosine theta 2 minus T1 times sine theta 1, T1 times cosine theta 1. This is just, so what is this? This is the vertical force divided by the horizontal force, and then vertical force divided by horizontal force. This is at the point Q, no, yes, Q, and this is at the point P. So that is just tangent theta 2 minus tangent theta 1, and that is equal to what? Well, of course, you know, these are the same thing, right? These two are the same. So what we are doing is this. Yani şurada I am just dividing this expression by t, which is constant. So this gadget divided by t, but here I am writing, instead of t, I am writing t2 times cosine, and here instead of t, I am writing t1 times cosine. So we get this gadget, and that is t2s are cancelled, t1s are cancelled, so we get just tangent theta 1 minus tangent theta 2, and that is just delta x times rho times u sub tt divided by t. Yes. Right? We know that this is t, this is t. Okay? All right. And then we do what? Okay. Now, tangent theta 2 is just u sub x at the point q, and this is u sub x at the point p, right? Because you see, this is the graph of the function u, right? U x t. So this is the x direction, this is the u direction. So the slope here is what is the slope? It is just the x derivative of this. X derivative of this function is just u sub x. What is this t? T is just a parameter which changes the shape of this curve. Okay, but for a fixed t, this is just a function of x, and the slope at this point just the x derivative of this function, which is u sub x, and the slope at this point is just the x derivative of the same function u with respect to x at the point q. Therefore this slope is just this gadget, and this slope is just this gadget. So what we see is that, so u sub x at the point x plus delta x minus u sub x at the point x, okay, of course I have t here, minus u sub x, x is equal to delta x rho u sub pt divided by t. Okay, the point q corresponds, right? Q is the point x plus delta x t, and p is just the point x comma t. So the x coordinate is x plus delta x and then t minus u sub x xt, and that's equal to this gadget. Well, dividing by delta x, we get what? And then here we have delta x, and that is just rho times rho over t, and then u sub tt. And then you do what? Let delta x go to 0. Letting delta x go to 0, we obtain what? The limit of this guy, assuming that u is differentiable enough, just u sub xx xt, and that is just rho over T U sub tt xt. And that's the wave equation. So we write it this way: U pt is equal to c squared u xx, where what is c squared? C squared is just T over rho. Okay, so this constant is determined by the tension divided by this density. Okay, tamam mı? So we obtained our wave equation. This is a positive number because, you know, T is force, the tension, it's a positive number, rho is a positive number. And to indicate that, we write c squared, meaning that it is positive. Okay, of course, it determines whether the equation is elliptic or hyperbolic, right? The sign of this number. Therefore, it is important to write I mean c squared here. So this is just you know, this is u sub t xx minus c squared u sub xx equals 0. So a is 1, b is 0, c is c squared. So what is delta? Neydi delta? B squared, right? Minus 4ac. So it is just minus 4c squared, which is negative. Therefore, this is hyperbolic. So it is an hyperbolic equation. Sorusu olan var mı? Yukarıya kaldırayım mı? Okay. Neyse, wave equation'ı da derive ettik, değil mi? Nereden geldiğini biliyoruz artık. Bir dahaki sefer gitar çalarken aklınızda bulunsun. Evet. Minus yanlış mı oldu? Ha, bu eksi c kare. O zaman burası artı c kare. Ha, o zaman zaten buna hyperbolik diyorduk. Tamam. Okay, yes. Ben genelde şey diye aklımda tutuyorum. Aynı işaretliyse türevler eliptik, ters işaretliyse hyperbolik. Yani hepsini bir tarafta yazdığımız zaman elipsle hiperbol arasındaki fark başka bir şey değil. Okay. Now we have the theorem about uniqueness. Let u1 xt and u2 xt be two solutions of this problem. So partial differential equation is the wave equation. U sub tt is equal to c squared u sub xx on a finite interval like this. So like gitar string. Şöyle kabul edelim şunları. Boundary conditions U0t equals AT, ULT equals BT. The two ends of the string might move, so that's not, of course, what happens in a guitar string, but this is more general. And initial conditions ux0 equals f of x. And we have also initial velocity. This is the initial position of the string, and this is initial velocity of the string. T derivative, right, is just the vertical velocity of the string. And it is for t equals 0, so it is the initial vertical velocity of the point x. Okay, so when you, for example, hit the string, right, you give an velocity, initial velocity. Yani tele vurduğunuz zaman, değil mi, hız veriyorsunuz. Ama böyle çekip bırakırsanız o zaman hız yok, ama initial, o zaman position var. Okay, so if you hit the string, then you give something like this. Okay, so what is the conclusion? Then U1 xt is just U2 xt for all xt. Değil mi? So there is a unique solution. If we didn't have a unique solution, then we couldn't have play guitar. Why is that? Yeah, each time you try to play the same thing, different sounds would would be created, değil mi? Nasıl? Ha evet. Burada eksi sonsuzdan artı sonsuz. Ama yani evet. Onu sonra göreceğiz. Tamam mı? Zaman bitti mi? Ha. Hoca çok korkutmuş sizi. Okay, so what's the proof? Yani existence, uniqueness olmasa hani gitar çalınamazdı, değil mi? Saz da çalamazdık. O yüzden hani teoremleri appreciate etmek lazım. Okay, now well, what is V sub tt? It is just U1 tt minus U2 tt, and V sub xx is just U1 xx minus U2 xx. Therefore, okay, since both U1 and U2, since both U1 and U2 satisfy the wave equation, we obtain what is VTT minus C squared VXX. Well, it is just U1 TT minus C squared U1 XX minus, right, U2 PT minus C squared U2 XX, but both of them are just 0. So we get 0. Therefore, this is also a solution. And it also satisfies homogeneous boundary conditions. V0T is just U1 0T minus U2 0T, but this is just AT minus AT because both of them are solutions of this problem. So both of them has AT at the end point, x equals 0, and at the end point, x equals L, U1 LT minus U2 LT, and this time this is BT minus BT, and this is also 0. So V satisfies homogeneous boundary conditions, and the initial condition, this is just U1 x0 minus U2 x0. Therefore, this is just neydi bu? Gx. I am sorry. Gx minus Gx. So it's also 0. So we have the following. Vtt is equal to C squared V XX, V0 T equals 0, VLT equals 0, and Vx0 is just also 0. So all the initial and boundary conditions are 0. And then we have what? Evet, o da var. Okay, yeah. This was actually F. I'm sorry, this was F. Yeah. And so similarly, we obtain V sub P, right? X0 is just Gx minus Gx, so that's also 0. So we have this V sub T. So initial velocity is also 0. Then we have the following. Okay, now Vxt, let's write this. Well, this is just Vxt minus Vx0 because Vx0 is just 0, but that is equal to what? Just 0 to P V sub T X S ds, right? You just evet, yani işte ikinci değişkene göre türevini alıyoruz. İntegralini alıyoruz. So what is this? So by the fundamental theorem of calculus, this is equal to this gadget. But we know that okay. Şöyle devam edeceğiz. Well, we don't know anything about this one. We know that it is Okay. At 0, it is 0, but at any point, we don't know what the value is. Okay. Şimdi şöyle yapacağız. Claim is this. V sub t x t is 0 for all x in 0L and t. Of course, this claim, note that the claim implies, well, if the claim is true, then of course this thing is always 0. So the definite integral would be 0. So v would be 0, but v was just u1 minus u2. So this is 0. Therefore, u1 is equal to u2. So the claim finishes the proof. Okay. So all we need to do just to prove the claim implies that u1 xt is equal to u2 xt. So we just need to prove the claim. Proof of the claim. Let's see the proof. Okay, now consider the function ht, which is just integral from 0 to L c squared v sub x squared xt minus, no, plus, sorry, v sub t squared xt dx. So integral of this with respect to x. Tamam mı? Şimdi onu şöyle yapabiliriz. Okay. Now, let's take the t derivative of this. Then, t derivative of this is what? This is a definite integral. So to take the t derivative, I can just take the t derivative of this with respect to, I can just take the t derivative of this. You see, integral is with respect to x. So I can just put it inside. Bunun t türevini alırsak ne çıkar? Bakalım. Tabii orada yani türev integralin içine girer vesaire, analiz bilgisi gerektiriyor ama hani burada onları kabul edebiliriz. 349'da so you need actually analysis knowledge here, right? How you can take derivative inside integral and so on. But I'll just assume that here. And then when you take t derivative of this, we get what? By the chain rule, we get 2 times c squared v sub x. So this power is reduced xt, and then derivative of this gadget with respect to t. So which is just vxt xt plus t derivative of this is just 2 times v sub t xt times t derivative of this, which is v sub tt xt. And then I have still integral with respect to x. Yes, so let me just write it this way. Şurada iki parça olacak. So 2c squared and then integral from 0 to L. Okay, so here v sub x and then v sub xt plus uh, 2c kare hepsinde var mı? Olmaması lazım. Ha şunu kullanıyor. Tamam anladım. Okay, now instead of this, since we have v sub, what was our equation? V sub, okay, vtt is equal to c squared vxx. So we just use it here. So instead of this, I write c squared v sub xx. So we get 2c squared. That also goes out. So we get just v sub t and then v sub xx. And then I have dx. Okay, so I get 2c squared integral 0 to L. This expression, what is this? This is just the x derivative of the following expression. Bu neyin x'e göre türevi? Vt ve v'nin, değil mi? Şu ikisinin çarpımının x'e göre türevi. Bunun x'e göre türevini alıyorum. Vx. Ha evet. Dx. And that is equal to what? Okay, so that's equal to 2c squared. Well, here I am taking x derivative and then integrating with respect to x. So by the fundamental theorem of calculus, we just cancel this 2. So just this gadget evaluated at L and 0. So that is just by the fundamental theorem of calculus, v sub t times v sub x evaluated at 0 and L. So of course this is x equals 0 and L, but we know that v sub what was our conditions? Yeah, so v sub t, this is 0 at x equals 0. X equals L'de de x equals L'de de o niye 0? V sub x. Oh, okay. You see, so neye ihtiyacım var? V sub t şimdi şöyle diyeyim. 2 V sub t L0 V sub x L0 minus, pardon, bu LT, bunlar T minus V sub T 0 T V sub x 0 T. Okay. So I know that V sub T x0 is always 0. Oh, this is always 0. No. This one is yok. T eşittir 0 ise 0 o. V L T. Bir dakika. Bunlar niye 0? Şöyle düşünmek lazım. Okay. Now this is 0 for all x, right? This is 0 for all x. So if I differentiate with respect to x, it is still 0. So p sub x x0 is 0. And that is o zaten burada da aynı şey var. So here when I differentiate with respect to t vt 0 t equals 0 vt l t is 0, right? Because they are 0. Vt 0t, it is this one. VTLT, it is this one. Right? So VTLT is 0. VT0t is 0. Therefore, this is 0. Okay, so this finishes the proof. So the argument is that this is 0 for all t. Therefore, t derivative of this is also 0. And t derivative of this one is also 0. Right? This is the function of t. And it is constant and equals 0. So its derivative is 0. And the same thing here. Okay. Neyin? Özür dilerim. Tam bitmedi. Okay, so this means what? This means ht is constant. So h prime, this is 0, implies ht is constant. Onu da bir noktada hesaplayacağız. T yerine mesela 0 yazsak, h0 nedir? H0 is just 0 to L 2c squared v sub x yok v sub x squared 0 t plus v sub t squared 0 t dt. V sub x 0 t is just Ee, nasıl? Ha, bunlar t yerine 0 koyduk. Pardon. 0. Okay. X 0. Ha, türev almadık. Şu da yok. Sadece böyle. V sub x x 0 0 koyduğumuzda efendim c kare var. V sub x o zaten 0. V sub x is 0 because of this. This is 0 for all x. Therefore, V sub x is 0. So this is 0. And V sub t is evet, that's already given here. V sub t x 0 is 0. So this is also 0. So this function is constant, and at one point it is equal to 0. Therefore, this is equal to 0. And this is equal to 0 means, so, you know, this function is constantly 0. But you see, this is never a negative function. This is always non-negative. But its integral over an interval is 0 implies that this function must be identically 0. So this function is 0. And that is 0 means, since these terms are also squared, okay, both this derivative and this derivative is 0. So that implies V sub x t is 0 and V sub t x t is 0 for all x and t. But, you know, these partial derivatives are always 0, implies Vxt is 0 for all xt. Okay. Yes. Değil mi? Öyle olması lazım. Ha, evet, evet. We just needed V sub t x t 0. Okay. Tamam. Okay. So let's stop. Oh, çok zamanımızı almış.